We will start with a quick overview of the graph editor before we go into details explaining the nodes and how to manage them. To create an AI graph, go anywhere in your project, open the context menu and navigate to AiMalgam. You will be greeted with different kind of settings you can create, such as actions, states, runtime, deciders, conditions, comparers, and finally the node graph. Creating a new node graph will automatically open it. With the graph editor, you will be able to create an AI decision flow, which leads to actions the AI will execute in the game environment. You will design the flow in the main grid area by managing the node settings and their connections, leading or linking to other node settings. At the top left corner of the graph editor, you will see a side panel you can collapse or reopen with the chevron icon. The current open tab in the side panel, called Manage Assets, consists of different node settings you can create, manage their file location, which is by default the same location the graph editor is located, or find already existing settings of the type and put them in this opened graph editor. On the right hand side of the side panel, you will see 3 different buttons which control the complexity of the graph, meaning how many nodes and connections are shown. As you can see in the side panel, the available node settings you can create either shrink or grow, depending on the visibility button pressed. It is recommended to either work at the minimum visibility or average visibility, since it can get confusing when too many nodes and connections are displayed. Furthermore, you can save up some performance if less nodes are rendered at once. Pressing the small search icon on the right hand side of the floating buttons will select the graph editor itself, so you can find it in your project at any time. The middle tab of the side panel shows the node inspector, which displays the settings of the currently selected node either within the graph or outside the graph. It acts as a default Unity inspector. Multiple node editing of the same type is supported, since we are dealing with scriptable objects. Lastly, on the left hand side you will find the Graph Inspector tab, offering by default to collapse the nodes when panning the grid area or selecting other nodes. While working with many nodes in one graph, it is recommended to leave those options on to maintain a more stable and smooth performance, since rendering multiple scriptable objects at once can be quite costly in Unity. Below those options, we will find decider nodes that have a special position in this graph by being called on awake, on enable, on start, or being the root node to traverse the AI decision tree. Below that, there's a list that showcases the required engines for the actions that are found in this graph, or rather the action settings. And lastly, a list that displays all the nodes that are hosted in this opened graph editor. Now we will go more into detail. At first, I will show you the features of the context menu. You can access it by right-clicking anywhere in the grid area. The first option allows you to create node settings of different types. Notice how the available node settings you can create again increases or decreases depending on the visibility you select at the top left. When you create a node, its location is by default the same location the current node graph is in, unless you change it in the Manage Asset side panel. Another exception to the creation path is if you clone, copy or duplicate an existing node, then the location is the same as the cloned or copied node. As you can see, dragging the node collapses its body, as enabled in the Graph Inspector options, which you can turn off at any time, of course. Notice some nodes disappearing if you change the visibility. This does not mean that the nodes are deleted or are not hosted anymore in this graph. They still maintain any connections you have made or store any changes you have made on them and remain at the same positions. It's just the visibility that has changed, so you have a better overview and furthermore save some performance rendering the graph editor. By holding the left mouse button, you can drag a selection grid to select multiple nodes and perform group actions on them, or edit multiple nodes of the same type, or move a group of nodes to another position. Or, like in this case, delete multiple nodes at once permanently, meaning that the scriptable objects are also wiped from the project. Notice that the Undoredo history is cleared to prevent Undoredo bugs when trying to reference already deleted scriptable objects that cannot be recovered anymore. The next context menu option opens up the node editor preferences. Here you can configure global graph editor settings such as the footer colors of each node setting type, the general graph editor appearance like the grid color, the accepted or invalid node color when using the graph debugging of a runtime AI entity instance, or if the graph editor should autosave, while it is still recommended to manually save once in a while. This can be achieved by either pressing Ctrl S on Windows or Command S on Mac. If you create custom node settings, they will also appear in this node editor preferences window. If you have already set up node settings, you can add existing ones to the current opened graph editor by choosing the Add Existing Node option. Notice that if you add an existing one that connects to other nodes, meaning that its input ports are connected to other output ports, it will drag those dependent nodes automatically in this graph editor as well. Also be informed that if your visibility is set to average or minimum, you may not see dragged in nodes since they are invisible, so keep an eye out for that. If you ever get lost in the graph editor, you can simply right click in the grid area and focus on all nodes or on the selected nodes. It is also possible to copy and paste node settings. This can be either achieved by right clicking on the node you want to copy or by pressing Ctrl C or Command C on Mac and Ctrl V or Command V on Mac, anywhere in the grid area. To remove nodes from your graph editor, which you don't want to delete permanently, you have two options to do so. Either remove them and keep connections to nodes that are still in this graph editor, or remove them and lose connections to nodes that are in this graph editor, but they will still remain in your project and be still available in other graph editors. By pressing the delete key, you will also just remove them from the graph editor without deleting them permanently, but the connections to the nodes that remained in the graph editor will be cleared from the removed ones. Notice that the connections of the removed ones will keep intact. So if you remove a group of nodes that were connected between each other, they will maintain the connections as long as they are within that group that you removed. Up next, I will explain the node header, body and footer. On the top left corner above the node's header, there's a number displayed. It indicates how often this node is used in other graph editors, including this one. If there's no number, then it means that this node is only referenced in the current opened graph editor. In the middle above the header you see text displayed. This is only for decider nodes that have a special assignment for this graph editor. In this case it is a root decider and it is called onStart of the mono behavior that references this graph editor. In the header area you will see the name displayed of the node, or rather the name of the scriptable object, and on the left hand side is the icon for this node type. The node body only displays output ports or visible input ports, depending on the visibility setting on the top left corner of the graph editor. Normal fields that contain primitive data or reference non-node objects are not displayed in the graph editor. They are only visible in the side panels, node inspector, or any other normal Unity inspector. In the footer you can see the node type color. On the left side is the base color and on the right hand side is the specific node color. With this color indication you can always spot certain base node types like action settings or decider settings or condition settings, even custom settings you have created, while still being able to differentiate the inherited ones and also know which input port would be compatible that supports inherited nodes of the base type it represents. As you can see, when you tamper with the visibility settings, the node body either shows more input ports or hides existing ones, depending on if the connected nodes would be visible in the graph in the first place or would be hidden. Right-clicking on a node opens another context menu. The first option, only being visible for decider nodes, is to assign a specific role to the decider node, like being the root decider or being called onStart, awake or onEnable. The second option, also being only visible for decider nodes, is to revoke the special assignment. Notice when removing the root assignment, the graph editor pops up an error message at the top left corner. This is because a root decider is mandatory to make an AI decision, since the decision tree must be traversed from a specific root decider in order to reach the desired action settings. The next context menu option opens up a small pop-up window that showcases in which graphs this node is hosted in. By clicking on the graphs, they will be selected and you can see where the location of the selected graph is in your project. The context menu option Move to Top will render the selected node above all other ones. You can also rename the selected node. Notice when you select the nodes in the graph editor, they will also be selected in your project and the project window will navigate you to the location of the selected node. Make sure to save once in a while. You can copy or duplicate nodes as well. Notice that the input connections will remain the same. The copied or cloned node's location is where the original node is located at. Up next, I will show you the difference from removing a node while clearing its connections and removing a node while keeping its connections to the nodes that are still remained in the graph. As you can see, the nodes still exist in the project since we did not delete them permanently. You can also just drag and drop nodes in the graph editor. But notice that if the node already exists in the graph editor, there will be a warning displayed. Also, be careful when you drag in nodes that will be hidden immediately. So it might appear that the drag and drop did not work. Although the node is in the graph editor, it's just not visible. As you can see, one node we removed maintained its connections and the other one lost its connections. The most fatal way to remove a node is to delete it permanently. Doing that will also clear the InnoReader history, so be careful. Don't be afraid to delete or rename nodes outside the graph editor. It works perfectly fine, but you should keep an eye out where you might have broken some connections. To delete nodes, it is recommended to either use the control panel or do it in the graph editor, so you can also inspect where it might have been referenced. The last option clears all list ports. Beside the grid area context menu and the node context menu, you have also a port context menu. When you hover over an input port and right click on it, some options will be displayed here as well. You can disconnect specific ports, reorder the port list, connect ports by either dragging an output port to an input port or by dragging an input port to the desired output port. If you want to get rid of all connections across all graphs this node is used, you can simply click Clear Connections. Some nodes may be far apart, so it would be very tiring to drag an input to an output port via the entire grid area. So you can simply connect to a node that is within the graph by right-clicking on the port and choosing the desired target node. If you want to connect to a node that is already set up and within your project but not within this graph, you can right click on the port and choose to add an existing one, and it will display those which are compatible with the port. If you want to quickly expand your AI tree, you can right-click on the input port and create the compatible one via the Create Options menu. As you can see, if you remove the node that is connected to the input port while keeping its connections, the name is still displayed in the list item. Reopening the graph will cause the node to reappear. You can also add anchor points to your direct connection. Currently it is not possible to move the anchor points, but you can delete them at any time. Up next we will cover the side panel in detail, starting with the Graph Inspector. If you ever get lost, just press the Focus on all nodes button. By default, the node bodies will collapse when panning or selecting nodes. You can disable the option and see what happens. To get rid of the root decider warning, you need to assign a decider as a root one. Notice on the left hand side in the side panel, you see that the name of the decider appeared in the assigned deciders list. You can click on it to select it, and if you click on the search icon, the node will be focused in the graph editor. Different decider nodes can have a different assignment, but not the same one. Below the assignment list in the side panel, you see there's a required engines list. This list displays what mono-behavior engines are needed for the AiMalgam entity to run this graph. This is because the action settings will be converted into action objects that can only run on their respective engine. If you don't want to handle multiple engines for one entity, it is possible if you create your custom engine and actions pack, which will be covered in another video. Adding or removing action settings will update the required engines list respectively. Last but not least, there's the nodes list, where every node setting hosted in this graph is displayed in here. Notice if we change the visibility, the search icon either appears or disappears, since you cannot focus on a node that is hidden. Though it is still possible to select and edit the node in the node inspector. Selecting the nodes in the side panel will also navigate you to the location of the node settings in your project. Up next we have the node inspector you can select by clicking on the middle tab of the side panel. It is a regular Unity inspector which allows multiple editing of the same scriptable object type. The button Show Graphs containing this node will open exactly what it says. A pop-up window will appear displaying where this node is also hosted in. The Manage Assets side panel displays all node settings you can create or maintain the path where they are or where they should be stored. Changing the visibility will also change the list size respectively. The list is at first sorted by their visibility, going from minimum to maximum, and then by name. If you click on the Edit button, a folder picker window will appear. If you change the path, the created node setting will be stored in your selected path. By default, the path matches the location where your node graph is. Again, you can delete your settings at any time you want. Just keep in mind that the setting might have been used by another graph, so be careful. As always, you can also add existing nodes by clicking the rightmost button of the three. That's it for the graph editor mechanisms. Check out the manual and other tutorial videos to find out how you create your own custom AI actions, engines and settings pack, as well as what the node setting types do and what their purpose is, and how the tree actually works in the first place.